Okay, so today we have an implicit differentiation problem from the 2019 June examination for Math130, and it says use implicit differentiation to evaluate dy by dx at the coordinates xy is 0 and 1 given this equation. So the first thing I'm going to do is write down our given equation. So this is x multiplied by e to the y plus y multiplied by e to the x, and that's going to be equal to 1. So before I move on to the next step, I'm going to notice that they want dy by dx. So in order to get dy by dx, I'm going to have to take the derivative with respect to x. So let's say, okay, let's take the derivative with respect to x on both sides of my equation. That's going to be plus y multiplied by e to the x, and that's going to be equal to the derivative with respect to x of 1. So let's look at my first term. Okay, and I'm going to think about the derivative with respect to x of x multiplied by e to the y. So using the product rule, I'm going to leave my first function as is, deriving e to the y. The derivative of e to the x with respect to x is just going to be e to the x multiplied by the derivative of x, which is 1. So let's keep that in mind. Taking the derivative of e to the y, I'm going to say, okay, that's just e to the y multiplied by the derivative of the exponent, which is going to be dy by dx. Okay? And this is going to be a product rule, so I'm going to add. Okay, I left my first function alone, so deriving my first function with respect to x, I get that x is just going to be 1, and then copying down the second function, that's just going to be e to the y. So simplifying this to make this look just a bit better, this is going to be x e to the y multiplied by dy by dx, and this is going to be plus e to the y. So let's think about the derivative of the second term of my equation. So d by dx of y multiplied by e to the x. Now notice again that we have another product rule. So leaving my first function and taking the derivative of the second function. Remember that the derivative of e to the x with respect to x is just e to the x. So that's just going to be the same thing. And we have a product rule, so I'm going to add. Now the derivative of y with respect to x is just going to be dy by dx, and we can copy down the second function as is. Okay, now lastly, let's think about the derivative of 1 with respect to x, and we know that the derivative with respect to anything of a constant is just going to be 0. So now we have 3 important parts of our equation, and we basically have our solution already. So now all I'm going to do is just add all of these things together. So taking the first part, that is just going to be the same thing as x e to the y multiplied by dy by dx plus e to the y. Now I'm going to add this part. So that's going to be plus y e to the x plus, and I'm going to switch these two around. So I'm going to say e to the x multiplied by dy dx. And that's going to be equal to 0 because the derivative of 1 is just 0. Okay, so let's move all the terms without a dy by dx to the right hand side. So that's going to be this term and this term. So if I do that, I'm going to have, well, x e to the y multiplied by dy by dx plus e to the x multiplied by dy by dx is going to be equal to, moving these two terms, this is going to be minus e to the y and then minus y e to the x. So the next thing I'm going to do is factor out a dy by dx on the left hand side. So if I do that, this is x e to the y plus e to the x. And this is going to be equal to the same thing. So getting dy by dx alone on the left hand side, I'm going to divide both sides by this term, and I get that dy by dx is just minus e to the y minus y e to the x all over x e to the y plus e to the x. Okay. Now they wanted dy by dx at the coordinates xy is 0 and 1. So we can say, okay, at the coordinates xy is 0 and 1, we can say, well, dy by dx is going to be equal to minus e to the 1 minus 1 into e to the 0. That's going to be all over 0 multiplied by e to the 1 plus e to the 0. E to the 1 is just going to be e. E to the 0 is just going to be 1. And 1 times 1 is just 1, so it's going to be minus 1. This whole thing is going to be 0. And once again, e to the 0 is going to be 1. So I can say that's minus e minus 1 all over 1, which is just going to be minus e minus 1. And you could say this is approximately, what, minus 3.7 something. I'm not really too sure. But this is the final answer. So the value of dy by dx at the coordinates xy is 0 and 1 of this equation is just going to be minus e minus 1, which is approximately minus 3.7 and going on to infinity.